The
of that equation is the
y-intercept.
folding. Ooh, what was that, Jabulani?
The y-intercept.
The y-intercept. What does that mean? What's a y-intercept? Jabulani, what's a y-intercept?
That's the end. No, not like that. And not geograph. Y-intercept is listed as a B. The y is where the graph crosses the y.
You got it. Where your graph crosses the y-axis. So add this to your notes, everybody. You're writing this somewhere. Where graph crosses y-axis. I like how you said that. We also called this something else when we were graphing last week. Anybody remember another name we called the y-intercept?
The x-intercept.
If it comes to you, you can throw it into the chat. I'm going to leave the chat on today so you can participate that way as well. Okay. If the chat goes off math topics, then we'll turn it off. But I would love for us to use that as a way for you to engage in class. Okay, so right now we know the B is the y-intercept. It means where your graph crosses the y-axis. Let's be thinking today for other ways that we can be thinking about our B or our y-intercept. Okay, to get started, let's look at these beautiful lines. Linear equations, A, B, C, and D. Go ahead and throw into the chat something you notice that is the same between two lines and a noticing you have for something that is different between the two lines. Go ahead and throw it into the chat. Something the same, something different. We are on page 209. Thanks, Paula. Arnica said B and C both go through the origin. There they do. Great noticing. So that is something the same for B and C. Ashin says A and B are parallel. They are. So Ashin, I'm going to push you. Then what is the same about those graphs? If they are parallel, what is the same? It's a good catch, right? A and B are parallel. So reminder, we are working with y equals, yes. Ashin said the unit rate. You got it. The unit rate is the same. The slope is the same. Good. So if two lines are parallel, that means the slope is the same. They're going up at the same steepness. Yes, good. Question is, are C and D parallel? What do we think? You can raise your hand and speak, or you can answer in the chat. I love all this participation. Question is, are C and D parallels? One of your peers is asking. Arnica, you said yes, they are parallel. What makes you think that? Jabulani, you said yes. Why? Why do you say they are parallel?
Parallel means that they're apart from each other.
Mm-hmm. Which means they're going up at the same what?
At the same, going up 2 times.
Good. And Andrew, I love that word that you've used a couple times in there. Constant rate, the same rate. Good. And another word for rate? Slope. Good. All right. So we were just talking about C and D, yes? The slopes are the same for C and D. What is different with C and D? Slopes are the same. What is different?
Let's see. D D is in the negative axis, and C is still the negative axis. But C is not on. But C he is on the 0, but D isn't. Both
Okay,
gone up by 2.
good. So Jabalani, you notice C's y-intercept is at 0, which is what Arnica was saying earlier. C has a y-intercept of 0. What is D's y-intercept? Where does it cross the y-axis?
-2.
-2. So C and D have the same slope, but different what? Let's use that vocabulary word. Different y what?
Axis.
Y-intercept. Good. Say that out loud right now, wherever you are. Y-intercept. Practice that. Good. And our y-intercept again is held in our equation with the b added to the end. Good. Okay. Let's look at the next slide. So today we are going to work again with equations that are in that same form, in slope-intercept form. Y equals -3x plus 60 as an example of an equation in slope-intercept form. All right, we are on page 209 right now. Okay, let's read the problem. Hey, Kamaya. A 60-gallon rain barrel is filled to capacity. So just think about what visually that looks like. It's filled up to the top. Elena opens the stopper to let water drain out to water her garden. The equation y equals -3x plus 60 can be used to find y, the number of gallons of water left after the barrel drains for x minutes. So what is this problem about? What are the two things that this equation is comparing? You can throw it in the chat. You can unmute yourself and talk. Kamaya, what's the problem about?
Based on what I'm seeing, it looks like you're comparing -3x, which I guess in this case, I think x the unknown value along with y. And I think isn't the main equation chart you're trying to figure out what like, because doesn't y equal like m and x together? So is the 60 considered the m and then the 3 the x? I'm trying to remember because like, you know, we kind of went over it last week.
Right. Yep. And we were just talking about that before you came in here. You're on the right track. M is holding the place for what? B is holding the place for what?
The -3. The -3 would be M and 60 would be B.
Good. And what are they representing in our situations?
Slope and y-intercept.
Good. So slope is, in this case, -3. Okay. And the number added to the end, let me change my color here. That number added to the end, there we go, is our y-intercept. Good. So we've identified some specific information about this problem. My question to you is, what are the two quantities that are changing in our situation? What are we comparing? What is this problem about?
The
It
amount
was the
of
graph.
water coming out of the barrel,
What
And
was
like
it about
the
the water
rate?
coming out?
like the rate
much
at
water
which the
coming
water
out?
is coming out.
There is water coming out of the barrel. So that's one thing that's changing.
I think I'm starting to kind of get it. I think because we went over it last year too, I think.
Number of gallons of water left is one thing that's changing over
Oh.
time.
Maybe how long it takes for the water to drain,
Good.
or for 1 gallon of water to drain, or how
Good.
much water drains in 1 minute.
You got it. So
One of
really,
those.
you got it. So really important before we start jumping into these problems, you want to orient yourself to what are we talking about? What are the two things that are changing in this problem? So one, as time goes on, she unplugged that barrel, time is going on. So that's one thing that's changing. What is the other thing changing in this problem? What's happening?
The water level.
The water
Low
level
level.
is changing. So this problem is comparing time to the water level in the barrel. All right, so let's look at what they're asking us to do. So they're asking us to graph this equation, and look at that graph they gave you on page 209. Did they give you anything on it?
Nope.
Nothing. Okay. Wow. That's rude. All right. So let's see what we can do here. Now, we have a plus 60. What in our problem is 60? Any
Gallons.
ideas?
Down.
Gallons of the what?
Water.
Of water.
There we go.
Or
We know
weight.
that our water started at how high in the barrel?
Full.
Started full. So it must be starting up at what?
60.
60. From there, is that water level going to be going up or is it going to be going down?
Down.
It's
Down.
going down.
Good. So you want to keep that in mind when you are now going to be starting to graph. Okay. So let's use that beautiful straight edge that I know you have that's going to make a lot nicer X and Y axis than what I can do on my computer. So go ahead and draw in your X and Y axis. Now, reminder, our two variables, we have minutes and we have the water height.
Why?
Y,
Water.
good. So Y is our water height. X is going to be our minutes. In order for us to figure out what to graph or what we need to put on our x-axis here, so this is going to be our time. Should we figure out how long it's going to take for that barrel to empty? How could we do that? So it's starting up at
Division.
60. How much is it going down every minute?
Negative.
-3.
It's going down 3 gallons a minute. And what that -3 is our what of our line?
Slope.
Is
Oh.
our slope. Good. Slope, another name for slope is rate, correct? So are we
Right.
surprised then that the rate that water is going down then is going to be 3? It's going down 3 for every minute. So if it goes down 3 for every minute, then how much is it going to go down in 2 minutes?
6.
6.
6.
What about 3 minutes?
9.
3.
Nine.
9.
What about 4 minutes?
12.
12.
12.
See a pattern?
Yes.
Okay. So let's create a table of values here. Kamaya, question.
Yeah, but also it's just like I'm trying to make sure I'm following you guys here. So, are you basically saying for every -3 or to 60, are you saying the unit right for each is okay? If I say I was going to divide 60 by 3, just for example, so you'd have 1 and 20, right? So then for 2, you would have 40 and 2. Then for 3, you would have -3, you would have -3 and 60 for this one. They just keep going upward and upward and upward like that, or are we counting by 3s? Is what I'm wondering.
It's a good question. What do you guys think?
I think it would just go down by 3.
What is going down by 3?
The amount of water in the barrel.
Good. The water level, yep, is going
Yeah.
down
The water level.
3 gallons every minute. So that is the rate. So let's fill out this table because Kamaya, both of your ideas are kind of the same thing. And so I'm hoping that this table is going to help you find where they all fit. Okay. So let's
Right.
make a table that compares our two quantities. So X is our number of minutes. Y is what again? What is Y, everybody?
The
Water height.
So
Good,
water
the
height.
Water height. Good. So let's
Oh.
do water height here. So that is your y-axis. I can't write sideways. If I would, I could. Okay. All right. So when we have 0 minutes, it has not yet been unplugged. What is the height? What is our y?
60.
50.
60. It's 60 high. Okay. After 1 minute, what is our height?
-3.
Minus 3. So
Minus
what is
3.
the height?
57.
57.
Good. Okay. After 2 minutes, what is our height?
So 54.
4.
54. Okay. What about 3 minutes? What is our height?
51.
51. So for every minute, it's going down how many gallons?
3.
3.
3. Now, is this a good use of our time by writing all of these out here? Should we go all the way until we hit 0, a height of 0 to figure this out? Or is there like maybe a
No.
pattern we
No.
could use?
Do it like you do long division.
Okay. What do you mean by that?
Well, I mean like try to find the biggest thing that you can make out of 3 that
Okay.
fits into whatever number you need to divide by 3,
Okay, cool.
which in this case would be 20.
Okay, so we're for every 1 we go down. Or let me fix that. I lied. For every 1x, we're going down 3. Yes, with our height.
Mm-hmm.
Yes. A water height.
Good, water height. So we're going over 1, down 3. If I go over 2, what's my water height going? So in 2 minutes, my water height is going down what?
3.
Another 3.
6.
Okay.
3.
For every 3 minutes, my water height is going down what?
6. 9.
9.
1/3, 2 6, 3 ninths. What are these?
Oh. Fractions.
What are those things?
It's pretty
Fractions.
much the same thing every time. I mean, it's
Very-
the same fraction.
It's the
If
same
you really
fraction.
think about it.
They're equivalent fractions.
1/3.
Good. So let's give ourselves some friendly numbers to do, shall we? Because remember, our overall goal is to graph. So let's do that with friendly numbers because I don't want to graph 3,51. That's going to make my brain hurt. Okay. So what about after 5 minutes? How much will I have gone down?
Let's see.
15.
15.
15.
Then that would mean.
We okay with that? In 5 minutes,
Yeah.
we've gone down 15.
30.
Yeah.
Okay. So let's
I
write in this coordinate pair there on my graph. After 5 minutes, what is my water height now? Gone down 15. What is it?
I think I kind of get it now. You're just basically doing multiples of 3. It's like if you think about it,
Doing
1 times
multiples
3
of
is
3.
3.
Good.
2 times 6.
Four
Wait, no,
times.
6 divided by 2 is 3.
45.
Divided by 3 is
Good,
3.
Jabalani.
Yeah.
Good. So we've gone down 15 gallons. We started at 60, so we're now at 45. Isn't this a beautiful coordinate pair to graph? 5,
Yes.
45. Beautiful. All right. Well, let's do it again. Let's go up to 10 after 10 minutes. It's going to go
30.
down another what?
30.
It's going to go
Wait, no,
down
no, wait,
another
take that
15.
back.
Good. So
Oh,
we're at 30.
115?
Oh,
Oh,
30.
I got. Oh. Now I'm
Why-
confused.
why is
Oh,
this
wait.
30?
Based on what I'm seeing, I'm just like, because
Because 10 times 1/3 is 10/30.
oh yeah, good connection.
Great connection. So what's 30 then in this problem?
Uh,
Half of
get-
60.
Good.
It's
of
half
60.
the height.
yeah.
Good. Half
Half
the height. What? So in 10 seconds, we've gone down half the height?
I mean,
10
10
minutes.
minutes.
Oh, 10
apparently,
minutes.
yes.
Sorry. So
Apparent.
that's pretty powerful because then what if I double it again? What do we expect the height to
It would be 0.
It
Zero.
what? Wait. Oh yeah, that cut.
Zero?
It'd be empty.
Z- But but 0 though. I'm like, I mean, I kind of get it, but I like it makes sense, but it doesn't make sense. Like, how do you? I would think that you would at least get 0.6, if anything, but man, yet again, I could be wrong. But if it was 20, maybe 15. I'm like, I don't get how she gets 0.
How do we get 0?
I'm like, I don't get it. Like, how do you go from 10 to 0 with that? Wait, I can't actually.
You don't go from 10 to 0. You go from 30 to 0.
Oh, never mind. I get it. Now, actually, take that back. I get it. Because, like, it's 2 and 6, but you can always think of it as like 2 for like, as like 0, like 0 to 6. Like, if you see the fraction, like, I don't know if I can still, apparently we can't annotate, but you can think of it like as like, you see the 2 over 6, right? You could just like flip it. Like, I could add the zeros, but since there's already 60 here, man, I'm trying to find the right word for it, but
Vincent,
almost-
I saw your hand up, Vincent. What do you think? Why are we out of water at 20 minutes?
I think that it goes from 30 to 0 because it's just 10 to 20 and there's no difference. It's just we don't have the stuff in between.
We don't have the stuff in between. Can we make stuff in between? Can we find some coordinate pairs in between?
Yeah, because
Yeah.
11 would be 27 and it
Okay.
keeps going on and on.
Good. Okay.
And
So you said
and it-
after 11 minutes, it would be a height of 27. Okay. Let's do another one.
24,
And then 15 would be
21.
After 15 minutes.
after 15 minutes
One,
it would be
3?
it would be
No,
15.
5.
Actually, it'd be 15 over 15, I think.
No.
Yep.
What do we
what?
think? Let's
Maybe-
go back here. Notice we went
That-
from 5 minutes to 10 minutes. So that had a change of 5. Yes.
Oh,
How much
I
did the
think
water level go down in 5 minutes?
I think I get
15.
it
So
now.
yeah, it is
15.
15 over
Good.
15.
I
Good.
get it now.
Good.
But
So from 10 to 15, if we go up 5 minutes, our water level will go down
Ew.
15.
Every 15, I think I get it now. Because you
Good.
see, I'm seeing a pattern now. Like,
Good.
you see 45 multiple of 15. Well, they're all multiples of 3, but 15, then 10, you go down another 15. 15, you go down another 15, and then once you get to 20, you're out. Pretty
You're out.
much.
Hey,
Now I
Andrew.
get it.
Andrew,
Now
what were
I-
you saying in chat from the very beginning? Andrew? It's a good time for your wisdom. These work this way, these patterns exist because we have a constant rate. So fall back on that, okay? And our constant rate for this problem is 1/3. So anything, or excuse me, is down 3, Okay, we're going down 3 for every minute, down 3 for every minute. Good. You got it. Constant rate. Beautiful. Okay, so how this is helpful for us, thinking it as a table of value, is it helps us graph. So let's go ahead and graph now. What is our highest height that we need to get up to on our y-axis here? The highest y
60.
value is 60. So it's important to know that before you start throwing in numbers, because it helps you plan. We want to use as much of our coordinate grid as we can. So what do you want to count by if our highest point is going to be 60? Let's see. Fives? Just kind of spitball it. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60.
10.
If we counted by fives, that would get us right here. And that gets us, notice, to a pretty high spot of our graph. So I like that. So on your book, you can do you could do every other for 10, or you could do every box as 5. So drawing in your axes is a really important part of graphing. You don't just start plotting points. This is the first step, to label your axes. Hopefully yours looks way nicer than mine, right? Okay, so once we have our y-axis set up, now let's think about our x-axis. Our lowest time is 0. What is our highest time we're going to need to graph? What was our highest x value? When did our water run out?
60.
When does our water run out?
20.
20.
20. So we need to make sure that we fit 20 on our x-axis. So what do you want to count by where we can fit 20?
Definitely 5.
5,
Yeah,
5,
agreed.
10, 15, 20. If I counted by 5s, that only puts me right here. Am I using a lot of my graph?
No.
No.
How about 2s?
Let's try and have that 20 end up over here on the right side. So then we have a nice, beautiful graph. 2s, let's try it. Test it out on your own. Does 2s help us get to the far right? 2, 4, 6, 8, 10, 12, 14, 16. I think 2 will work.
4s.
Yep, Arnica, great strategy in the chat. So your job when you're picking axes, scales, is to pick friendly numbers. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There we go. That's how your brain did it. That's perfect. Another way to find out 20 quickly, how many 3s fit in 60 gallons? If we have 60 gallons and it's going down 3 gallons at a time, how many 3s will fit in 60?
About 20.
Exactly 20.
20.
Yes. Good. So that's a faster way to get that 20. Good. All right. Only once you have your axes labeled can we now put on coordinate pairs. Now, what's the shape of this graph going to look like? Is this going to be a wavy line?
No.
No. It's going to be a straight line.
line.
Because the rate
Why?
is
How do you
constant.
know it's going to be a straight line?
Because the rate is constant.
Ah,
Yeah.
love hearing that.
At the
You-
constant rate.
Beautiful language, constant rate. Good. So really, we only have to graph 2 points on our line. However, the more you do, it kind of builds in a checkpoint. I like it because it's a way for me to check my math. So go ahead and start plotting your coordinate pairs. Your y-intercept is a really good one to put on there, 0, 60. Okay, what's another friendly one that we see on here that would make a nice? So 0, 60, we're gonna graph. Does anybody spy another friendly coordinate pair?
1030.
And
1030, that's very friendly. What other ones?
yes, that's a time.
Okay. I like 20, 0. That one's super friendly.
I like 15, 15.
I do too. That's very friendly. And also 5, 45 is also friendly. So any of those would be good ones to graph. So I'm going to go over 10, up 30. Who picked that one? That's a very friendly one.
Me.
Your hand hurt from writing. Same. Okay. 15, 15. Mm.
50, 50.
5, 15, 5, 45. Boop. Does this shape match what we thought it would be? The height of the water is going down over time. Good. All right. Then you want to take your double-edged straight edge, your piece of fancy folded paper. This is my own 8th grade son's. This is his that he leaves in our workspace. So he can always make those beautiful linear straight lines, crisp lines. I wish I had a double-edged straight edge for my Zoom. Ooh, that's really ugly, but good. Arnica, I need your good
It's
hand.
not
Can I
that
borrow
bad.
it? All right. It's not horrible. All right.
Not horrible.
Okay.
The answer,
Woo!
I was thinking the answer was 20.
You got it. You got it. Okay. Now,
I knew the answer was 20. You just had to divide it.
that's right. Now,
Oh, yeah.
I'm gonna try and make your brains hurt. Okay. And then we'll be done. And then we'll take the poll again. The poll will help your brains unhurt, but
Unhurt.
we're gonna talk about this point right here. Okay. This coordinate pair up here, it crossed the y-axis. We called this our y-intercept, right? Didn't we?
Yes.
Okay. What do you suppose this special point then would be called?
X-intercept.
This is your x-intercept.
There's so much vocabulary that goes into math.
Yes, there is. Now, here's where the brain hurt comes in. Okay. We were kind of trying to find this all along. When does the water run out? Okay. Let's think about this coordinate pair. What is the height of this coordinate pair? How far up is it?
By 5? Or
What is this coordinate pair? It's over 20, up what?
0.
20
Up 0.
0.
Your x-intercept will always have a y value of
0.
0.
0.
The height of your x-intercept will always equal 0. Okay, so here's where the algebra comes in, you mathletes. So let's take our equation.
Ouch.
Oh no, it's not head hurting time yet.
I didn't say I was.
You
I
have
meant like you said.
have said the
You said
word
you
algebra.
Okay.
You say you balance. I didn't mean my brain's hurting. That's not what I mean by that. Not that kind of ouch. Not that kind of ouch.
Okay, here we go. This is our equation, yes? Okay. Here's how we can use algebra. We want to know what is the x value when our y is 0. When our y, the number of gallons, is 0, what is x? So in algebra, whenever you're trying to find something and you have an equation, we can substitute in values. So we're going to force y to be equal to 0. What we are doing right now is we are going to find algebraically our x-intercept. This is what we're doing right here with the equation. So we substituted in 0 for y. Rewrite your equation that you have. We're left with negative 3x plus 60. We have ourselves an equation with only one variable now. What's our variable that's still alive? We substitute.
0.
Haley says x. Notice we still have an x in this equation.
Oh, you said
Let's-
you said variable. You kind of confused me
Variable.
for a hot second.
Let's solve this equation for x. That's what we're trying to find. We're trying to find the x value when our y value is 0. We're forcing our y value to be 0. Let's solve this equation for x. How do we isolate this equation for x? Dust off your solving equations skills. How do we get that x alone? What undoes our plus 60? Let's boot that to the other side. How do we undo plus 60?
Ooh,
Subtraction.
Subtraction.
Division.
Good. Recall your solving equations skills. So 60 minus 60 goes away. So we're left with the next step. 0 minus 60 is negative 60. Okay. Negative 60 equals what's still left in our equation? We still have a negative 3x.
Meaning you want us to get rid of the
Mhm.
negative 3.
That's what we're going to do next. How do I undo multiplying by negative
That's
3?
messed up.
Trying to get x alone.
I don't
yeah.
think
Divide
Divided by
negative 60
negative
by
60 gets
negative
us
3.
20.
Good. Divide both sides by negative 3.
I guess it makes sense because if you divide negative 3 by itself, all you're gonna get is like I don't know, like either 1 or just
A 1.
Ah,
Good.
oh
And a
yeah.
1x is the same thing as
1.
x.
Oh,
Yep, it's
oops,
the
my
same
bad. I
thing
keep
as
mixing
x.
myself up. Sorry.
Good.
Now you're hurting my brain.
Yep, good. That's the plan. That's the
What?
plan.
That's messed up, Miss Fergus.
We're
That's
left with
super
x
messed up.
equals. What's negative 60 divided by negative 3?
Negative 60 divided by negative
Negative
20.
Not negative 20.
20?
Positive 20.
What? Hold up.
A negative
Okay.
divided by a negative is a
Oh,
Oh,
positive.
positive. It's a
Negative
positive. Okay,
divided by a
now I get it. Yeah,
negative.
yeah.
That's
it's-
been a long time.
Oh.
It has been a long time. You guys have some cobwebs to dust off. Okay.
Ah,
Are
so
we
instead-
surprised that our algebra told us that when y is 0, x is 20 for this problem? Are we surprised?
If I'm understanding it right now, if I'm not, then yes.
Why
I
are you
guess
not
not.
surprised, Kamaya? Why are you not surprised?
Uh,
There's something in our table or graph that also aligns to the same information.
The X on the graph at the bottom.
I'm confused.
Yes.
Oh.
Vincent, keep talking. What about this point?
Well, I guess it's there.
It's right there. That's where
Yeah.
this point is on our graph. When x was 20, our y was 0, yes?
Oh, yes,
Wait,
that
so
makes
X
sense.
is basically the version of B? Its own
Yes.
version of B?
It's a similar version of b. We won't see it in an equation.
Oh.
A is equal
But
to
you guys just explored. You're gonna see
I gotta
the
get all
same
this stuff written
information.
down.
You're gonna see the same information, you guys, in your graph, which we see it right here. Do we see this point also in our table? Where x is 20, y is 0? Did we see it in our table? We did, right here. So table, graph, and now we just saw it in the equation. because we substituted in 0 for y. And what did you get for your x when we did that?
Wait, can you ask the question again? I just said.
We used the equation to substitute in 0 for y. And what did we get for x when we did that? You solved this equation. You got it right down here. What did you get for x?
0.
No, your y was 0. What was your x?
Oh, 20.
20.
So you now are seeing the same coordinate pair 3 different ways. This is algebra. What we're doing right now is you are using tables and graphs and equations to represent the same information. Okay, so it shouldn't be a surprise that we got the same coordinate pair when we used the equation. Okay, so the cool thing about algebra is that there's going to be multiple ways to get the same answer, which is amazing. Algebra is like my favorite kind of math because there's multiple ways to get to the final answer. Okay, here is.
Wait.
Go ahead.
Yeah, do you mind holding up for a second so I can finish putting the notes in? If you were going to change
we're
the
done.
thing?
I'm not changing. This is it. We're done. This is it.
Oh.
Yep.
We're done.
That's it. I think this was enough brain gymnastics for the day. Okay. Here's what, though, some things to be thinking of. If you are behind in math, you have some work to do in the next couple days to get your to get caught up so you can be satisfactory in your math class by Sunday at midnight.
Friday.
Okay.
Wait,
Yep.
Sunday midnight?
Yep. We're giving you guys an extension. Okay.
Okay.
Sunday at midnight. Good. And I see some great questions in the chat. What is math good for? It is good for a lot of things. However, the neatest thing about math that I tell my own children is that it helps with your critical thinking skills that can be applied towards everything. So here, how we can see the same coordinate pair in 3 different places in this problem, that's pretty powerful. Helps your logic, absolutely. Yeah. Absolutely. Okay, so week 10, week 11, week 12 needs to be done by Sunday at midnight in order for you to be satisfactory in math for the month. Okay?
Okay.
All right, I'm leaving this up here. Reminder, your teachers have their open office hours this week. Drop in. Mine are
Except for math.
Thursdays at 10. I don't know when Mr. Filings are. Who can tell me when Mr. Filings open office hour is?
He doesn't
Wednesday.
have office hours
Wednesday.
this week.
Oh, this week he
It got-
doesn't,
it
but
got
they're normally
canceled?
Wednesdays.
Yeah.
Okay.
Normally Wednesdays.
Okay. All right. So send your teachers questions if you have them. Okay. This week, let's make sure that you're satisfactory. You get completely caught up. Okay. You ready for that poll? Let's see
Yeah.
if it's changed.
Oh, I didn't even get to do it earlier, so it might have. Well, I don't even know what the poll
Why is
was.
he jumping forever?
Here it is. Would you rather
Uh,
parachute
No,
from
no, no, no.
5,000 feet in the air, or would
Oh,
you
we
rather
did-
bungee jump from 500 feet from a bridge?
We did this like we did this like a month
I
ago.
rather
The same
parachute.
one. Man, that's tough. I think I've never parachuted before. So yeah, I'll probably parachute from 5,000 as long as the parachute don't break.
I'm curious
That's
to
just
know if
me.
this changes.
Hmm.
Okay, couple more seconds.
Dang, that went by fast. I'm gonna just make sure I'm gonna leave myself. Never mind. Don't mind me talking.
Okay, closing it. 5, 4, 3, 2,
1.
Pretty much the same. Pretty much the same split.
It is.
Actually, no, I think
we
we have more
can't see it.
parachuters.
I can't
Hey,
see it.
I can't
We-
see.
Oh,
Show-
haven't changed. Oh,
show
sorry.
the
Here we go.
ball.
How's that?
Yes.
Oh, seven,
Yes.
71 to
Same
29.
score.
We have more parachuters this time. I think. What changed? If you went from bungee jumping to parachuting, what changed your mind?
Safety
Uh,
first.
Safety.
Besides, I've always wanted to see my house in the air.
That's nice. I mean, I would if I
Yeah.
didn't have any like safety on the butt. I don't even know what a bungee jump is. So, and I know what parachuting
I
is.
think
so
I know.
It's like, but still.
Amazing. Okay, you guys, I have to buzz off to game club. So if I see you in game club, looking forward to it. All right, I'll see you guys. Bye-bye.
Wait.
Yeah.
Wait, you said gaming club starts at noon, 12
Yep.
p.m.
Yep.
But I
It's like
had to
1
bed at
minute.
10 p.m. But I
No.
had to bed at 10 p.m.
Oh, it starts in 1 minute. Noon.
Oh.
12 p.m. means noon.
So
12
12
p.m.
a.m.
comes
means
before 12 p.m. comes before 10 p.m.
I know it
Yeah.
makes
a.m.
no
That's
sense,
AM.
right?
Yeah, I mean, technically speaking, it's not 10 a.m. It's not 10 p.m. It's 12 p.m. 12
That's
p.m.
right.
is noon, the middle of the day. 12 a.m. is midnight.
Okay, I have to go. All right, bye
Okay.
guys.
Later.
Happy Tuesday.
Bye.
Catch you later.